Okay, so look at another question here. It's a line integral. So this is the function x plus square root of y minus z squared over the path from 0, 0, 0 to 1, 1, 1. So it's given by two separate passes, C1 and then C2. So to work on the line integral, so the equivalent form here is right f of g of t, h of t, maybe p of t, something like that. The magnitude and then dt, right? So of course, this is corresponding to each of the paths. So for path 1, C1, v equals 1 and t, right? So the magnitude, or maybe let's call it v1. v1 here is going to be 1 plus t squared, right? And then for C2, let's see, v2 prime, it's the derivative of this one is going to become into 0, 0, 1. So the magnitude, it's as simple as just a 1 here. And both t are from 0 to 1, right? So what we can do here is we can, from 0 to 1, for C1 part, you can see x equals t, y equals t squared, right? And then z equals 0, so it's going to become into t, right, plus square root of t squared minus 0, and then square root of 1 plus t squared, right, and dt. And then plus, from 0 to 1, so it's going to be 1 plus 1 minus t squared, right? So it's a 1 plus 1 minus t squared, and then times 1, and then times dt. Okay. So all you need to do is just to finish this evaluation. So it turns out that is a 0 to 1, so this is going to be, this is t, right? So this is also t, so it's 2t square root of 1 plus t squared on dt. And then from 0 to 1, so it's a 2 minus t squared on dt. So for this one, you can just use a simple u substitution, right? So if you set u equals 1 plus t squared, and then du equals 2t dt, right? And then of course u, since t is from 0 to 1, so u is going to be from 1, right, plus 0 squared, and then 2, 1 plus 1 squared to 2. So before it was 0 to 1, but after you do the substitution, so it's going to be from 1 to 2. So this square root of u du, right, and then plus here. This one you don't need to do anything, so it's just 2t minus t cubed over 3 from 0 to 1, right? So for here, so it's going to become into u 3 half over 3 half from 1 to 2. And then plus 2 minus the third, right? So if you can simplify a little bit, that will give us, so we can factor this 1 over 3 half out, so that gonna give us is 2 over 3, so 2/3, right? So it's 2 to the power of 3 half minus 1, right? And then plus 2 minus a third, so becoming to 5 over 3, right? So it's 5 over 3. So it turns out what we have here, it's going to be so it's a 2 to the power of 5 over 2, so it's a 4 square root of 2 over 3 minus 2 half, and then plus 5/3, so that will give us is 1, right? So yeah, that's how to work on this problem. It's also very simple, very standard line integral problem.